Okay, so we got this situation. The equation of common tangent to the curve this. So we have first curve as y square equals 16x. We have second curve as xy equals minus 4. This is also equation of hyperbola. Okay, and this is equation of parabola. Okay, now look at this. How you will say that it is equation of hyperbola? So you can connect with that explanation. H square should be greater than AB. Okay, so with that you can prove that this is representing hyperbola. Okay, now look at this. We have to find out common tangent. So how we will respond? We have solved similar kind of questions in previous sessions where we have assumed y equals mx plus c to be the equation of common tangent. First we will substitute, means we have to find out m and c. So how we will do that? We will substitute this thing into the parabola. We will get equation 1 in terms of m and c. We will substitute the same thing over here. We will get another equation in terms of m and c, and we will put d equals to 0. So we got two equation, two variable m and c, and then we will solve to get appropriate value for m and c, and things are done. So this is the idea to solve this question. So how we will approach? Look at this. So let's substitute. So it is mx plus c whole square equals to 16x. Now let's write down this thing in standard form. So it is m square x square plus, I'll take 2 common, 2 mc minus 8x plus c square. So if you will take, like, just replace this x, you will get quadratic in x. So if you open this bracket and you will rearrange things, you will get this as your quadratic equation. Now you know that you have to put d equals to 0, correct? So put d equals to 0. So b square mc minus 8 b square minus 4ac. So 4 m square c square equals to 0, correct? Now can I divide both side by 4? Done. So we will get m square c square plus 64 minus 16 mc minus m square c square equals to 0. So this thing gone. So can I write mc equals to 4, correct? And if you will try to recall what is the condition of tangency in parabola, that is standard parabola, it was a equals to mc, amc. Okay, so we got first relationship. Now we will apply the same concept over hyperbola. Okay, and we will put d equals to 0. So let's do that. So x in place of y, I have to write mx plus c plus 4. Now please open the bracket. So m x square plus cx plus 4 equals to 0. Now write down quadratic in x. So can I do this? Look at this. You got quadratic in x. Now can I put d equals to 0, because we are talking to tangents. So we will have one touch equal roots. Okay. So b square minus 4ac, correct? So we will have c square minus 16m. Now can I find out value of c from here? So value of c will be what? 4 by m. So it is 16 by m square minus 16m. Can I divide both sides by 16? Can I divide both sides by m square? So we will have 1 minus m cube. Okay, if we will multiply both side by m square and we will divide both side by 16, we will get mq minus 1. So you can apply aq minus bq formula. So it is a minus b into a square plus b square plus ab equals to 0. You know that from here you won't get any real root. Okay, you will have only zeros from here. So we got m equals to 1. If m is 1, who will be c? C will be equal to 4. So we got value of m and c. Therefore, required tangent is, it is y equals mx plus c. Okay, just you have to substitute value of m and c in the given curve. Okay, so we got our desired tangent. I hope the idea is clear.